I was worried that it's going to be like literally just me. Yeah, no, not uh, yeah, yeah. So let's maybe wait for a couple minutes. Well, I don't know, like for like 1 minute, and then I'll just start. Yes, I think like half the people maybe don't have anything 5 to 6, and half the people have something. Yeah. Mhm. Yeah, I didn't actually. So like when I was booking the room, I like requested something, and they gave me this one because like for the summer I asked for UC and they didn't give it to me. And then I guess like they were trying to compensate. uh Even though like here, yeah, like it's not super convenient for me either. Yeah, well, I mean, like in the like there's not gonna be a winter really. Well, December is kind of like not as cold. Like maybe you're from Toronto and know exactly what it's like, but yeah. Are you? Oh, okay. Yeah. So yeah, I think like usually December is like not that bad. And it's certainly like nowhere near like whatever, like you have it like in Edmonton and Calgary or um yeah. Okay. All right. Anyways, I'll just do everything. So stop me whenever you want. So okay. So if we run this, so that is the code. So the question was, if we run this, why is it that, okay, let me just run it from scratch. So why is it that nothing shows up on the screen? And the answer is that there's no instruction to print anything, right? So the only way that the program would output something to the screen is if there is an instruction to print something. For example, if I had said print res, then I would compute res, which would be, square root of 25. And then here there is an instruction to print 5.0. Okay. So all right. So here B is if you add print, running the program produces an error. So here I said print res, but the question asks what's going to happen if I say print sqr. And that produces an error. So the error that it produces is sqr is not defined. And that's because sqr really only exists while my square root is running, right? So this is kind of like local variable, what we call scratch work. So something that exists while you're computing the square root. But once you've computed the value of my square root 25, so this is 5.0, you put it in res. Here, sqr is just nothing, right? So that is why it says sqr is not defined. So inside here, you could say print sqr, and that would be fine. Well, I mean, like you wouldn't usually do it, but it would work, right? So usually a function either has a job, so either its job is to print something or it returns something. So doing both is like usually not recommended. But you can do it, right? So that would work. So if I comment this out and I run this, that is fine. So the reason that is fine is so if I stop here on line 6 and I step in, so inside the computation of my square root, so the x is there, and now I will have computed SQR, so now SQR is there, its value is 5.0, And inside my square root, printing SQR is completely fine, right? On the other hand, so once I've returned, so here, now I'm on line 7. I've already computed my square root, and here SQR doesn't anymore exist. So, all right. So now we want a function that prints the square root rather than returns it, right? So this is so this would be in the output. So first I'll write my print square. This is square rather than square root actually. So I'm commenting it out, Control R. So this is what I'm going to run once I write the function. So I'm going to say def my print square, and it's going to take X. And the job is to print the square of X, right? So this is print rather than return. And that is because that is the job of the function, right? Is to print X. So the way I would ordinarily use it is by saying my print square, 30. So this would be 900. So if I run this would actually print 900, unlike before, right? So before, when we said just my square root or res equals to my square root, that did not by itself print anything because the job of my square root is to return 5.0. It's not to print anything. On the other hand, here there's an instruction, print X squared. So when you call my print square, that will actually print 900 because you'll get to this line here and that would print, 30 squared. No, so the main, you could have multiple main blocks if you wanted to, but the job of the main block is to just use all the functions, right? So you could, if you wanted to, have like another block that's like this. And so we kind of didn't completely explain what's going on, and we won't for a few weeks, but really this is like if name is main, blah, blah, blah. And then you're again saying if name is main, blah, blah, blah. So both would run, right? Because name is still equal to main, basically. So might as well just have the one. Technically also I like commented everything out. So this is just, this could be any nonsense that they want. Right. So really the only thing that exists right now on the main block is the call to my print square. So, okay. So the next question was, what's going to happen if you say something like this? So let's first run it and see. So why did it? Oh, because it's changed it from 30 to 25. So here, what happens is 25 squared, so 6 to 5 gets printed. And then you also see that none was printed. That's correct, yes, because my print square doesn't return anything. So it's as if it said return none. So that's basically the default thing that happens, right? So so that means that this has the effect that 6 to 5 gets printed, and then the value of this is none. So what gets assigned to res is none. And then when you say print res, what happens is that none gets printed. So you could also ask like explicitly here, like what's the value of res printed? It's going to say the value of res is none.
Did something and put it inside whatever the variable comes afterwards.
So it's not even so much that, it's that, or maybe I kind of like misheard. So exactly what's going on is that the value of so in the same way that the value of like square root of 9 is 3, the value of my print square 25 is none because my print square returns none. Right? So that's like literally what's going on. If the function doesn't split to return anything, the return value is just this special thing called none. Okay.
Have the return square roots.
Right.
With the square roots, then you whatever it is up there and have that value stored inside the square root.
It wouldn't. So this is, I think you're asking about this, right? So what happens here is the value of this gets computed to 5.0. And then the 5.0 gets put into res because there is an explicit instruction to put it into res, right? So if I had just said something like my square root 25, that would not store it anywhere. So it would compute it, but then it just discards it because there's no instruction to print it and there's no instruction to store it anywhere. So it's just gone. All right. So this is that. And then so that was kind of the explanation. So here we're asking to do tracing line by line. I think we've done it several times already, but let's just do it kind of quickly one more time. So I'll put the breakpoint on the first line that I think is going to get executed, pressing Control E. So at this point, what's happening is I'm about to compute my print square 25 so that I can put it into res. So I'll step in. So that's this button. So over here, once I'm on line 7, the 25 got sent to X. So I can ask, what is X? 25. And now 25 squared is about to be printed. So say next. So 25 squared got printed. And now the output of my print square 25, which is none, so the return value, got assigned to res. So I can query what res is. The answer is none. And now none is about to be printed, well, using the same instruction. So because it's the last line, I'll press continue. None got printed. That's what it is. All right. So, okay, so now we want to do the calculator. So basically what we want to do is we want to just like implement different functions that are kind of like what you would see in a Pocket calculator, right? So let me first start by kind of doing some. So I'll start by doing basically some test code, which is also going to help me just kind of get the handle on what it is that I'm supposed to do. So it should say something like welcome to the calculator or something, right? So welcome to the calculator program. And now I want to say the current value is what happened. So initially it should be 0. So I could, of course, just say the current value is 0, but I do want to change the current value at some point, right? So I'll say print current. And because of that, I need to set current to 0. If I run this, it's going to say the current value is 0. So now the first function is to add. So what I want to happen is if I say to add, let me look at what the examples are here. So, sorry, add. So add 5. So if the current value starts as 25, for example, add 5 should make it 30 and so on, right? So if I say add 5, I want the current value to become 5. So do I have like display current value? Yes. So I have a separate function that's going to display the current value. So that means that if I say display current value, that should print 5. Right? So that's kind of in the spirit of the examples that we've been doing, right? So what I want is I want to have current be changed, and then I want to print current. So we'll start by just doing display current value, which is like an easier thing. So that is basically going to be this. And in fact, now that I've written it, I can comment this out and instead say display current value. So what's going on here is that I have, and we'll explain why it must be global in a second. So I have this variable current, which display current value, its job is to print the value of current. So the way I want to interact with this is I want to be able to say add 5 and then display current value, and that should display 5. And because I'm not communicating anything to display current value, right? So it doesn't have any parameters. It must be that it just looks up the value of the global variable.
Do we have to define current global variable?
So that's a great question. So we don't have to explicitly declare that. So that's the technical term, declare. We don't need to explicitly say this because there is no local variable display current value here. So if we're using cur, it must be that it's global because that's the only thing that's available. When you're changing the value, then you must say that it's global. Here, you can say global cur, but it won't make a difference. So let's do to add. Sorry, this is add, and then it takes to add. And the idea here is, here I do have to say global cur, and then I would say cur is cur plus 2add. Okay, so this is kind of going back to communicating information to and from functions, right? So here, the way we're communicating with display current value is we're setting cur to whatever we want it to be. And then display current value just looks up the value of cur. The way we communicate information to the function add, it's kind of mixed, right? So the 5 gets sent to here. And then the way add communicates information to outside of itself is by setting the value of the global variable cur to something new. So let's see how that runs. So I'll put the breakpoint here. So cur gets set to 0. This is just printing. So here I'm saying display current value. So if I step in, here it's about to print the value of cur. Again, like the only place where we defined cur is over here. So cur is going to print 0. Sorry, the statement is going to print 0. So now we got to add 5. So what happens here is the 5 is going to get sent to add, and then we're going to change cur. So cur right now is just 0. Step in. So here, cur is 0, to add is 5. And we're about to put 5 into the global variable cur, which is also this guy. So do we return? Cur is now 5 because the job of add was to do that. And again, the last line, I'll just press continue, and it'll print the current value is 5. Is that making sense?
And so we just use one main block, and then we will just define that you want to put the
Right.
current value is current, whatever is in the main block is the variable, and going to be unit global in that one. And then we'll go into start doing things to it, so you have to define it as global.
Right.
And then we just change the value of this depending on what we want to do.
Right. Yeah, I think that's. Oh, right. Yeah. So, yeah, so that's basically kind of all there is to most of those things. So multiplication works the same way, right? It just like instead of add, it's like multiply. So the idea would be that we can do like 0 and then +5, and then you can say like mult7, and then this would be 35, I guess, right? We say mult7 to mult. So the reason there is an error here is this says to add, but really it should be named to mult, right? So I can say, +5 and then times 7, and that makes it be 35. So that's kind of the reason that cur is global, is that I want to have multiple functions that manipulate it. And it's kind of more convenient to keep it just like in one place. So let's do division. So the only thing here is that you're not allowed to divide by 0, right? So what you want to say is if to div is 0, then you want to do something else. For example, maybe you want to set the current value to error or something like that. Okay. So let's divide 35 by 2 or something. And then we display the current value. So that would be 35 over 2. So 17.5, I guess. So that seems fine. Let's try to divide by 0 and see what happens. So that's print error. So you might imagine, I didn't ask for it in the handout, but you might imagine that like the current value is error doesn't make sense. So you might say, if current is not equal to error, then we do that. Otherwise, we just print error. So that way we say error instead of like the current value is error, which is kind of weird. We can also, and that is sometimes appropriate, even though, usually you want to either return or print, but you can say, like if you're encountering an error, you can say like print like division by 0 error or something. Okay. And of course, like I can call this multiple times and it would be like 2 errors. Does that make sense?
So if you call it and divide it by 0, it'll print the error and then
Right.
so
So it will print the error message and it will set the variable current to the value error, like in quotes. So then, like when I next go and try to display the value, it will just display error. And here I did it twice, so it printed error twice. So that's what you see there. All right. So that's division. So I now want to do memory and recall. So the way it would work is I want to say something like memory here. And then if after I do memory, I say recall, what I want is for the old value to get printed. So the old value would be 35. Right? So basically, I want to be able to store whatever is the current value at that point. So at this point, the current value is 35. And then I want to be able to press the recall button. And what that would do is make the current value, whatever it was, on line 40 again. Does that make sense?
You don't have to define it, you just have to.
No, like that's, we didn't yet define it. So we will now do that. All right. So how would you do it? So the technique that we've been using so far, it would actually be kind of relevant, right? So it's just that right now we have like the one value cur, which stores the current value. So what we want to do is we want to have just another variable that's going to store whatever cur was when we called memory, right? So what I'm going to do simply say, so this is memory. And I'll just say memory equals cur, right? So when I call memory, what happens is I'll just store the value of cur in this variable memory. So let's try it. So I'll go here, step in. And here, so cur is right now 35. And here I'm saying mem is equal to cur, so mem is going to be the same. So I can query what is the value of mem. Okay, it's 35. And now I divide by 2 and display the current value. So cur is now 17.5, but mem is still 35. Right? So now memory stores whatever is the old value. So now if I want to recall, I just do the other thing, right? I just say, global cur is equal to mem. So that would make it so that whatever mem is, cur is going to get set to that value. So let's try that. I put the breakpoint here. And I run this. So at this point, cur is error, right? Because that's what it is here. Mem is 35 because the effect of this was to set mem to 35. So now I'll step into recall. And it's going to say, okay, current equals mem. So current right now is error, but it's about to be set to 35 again. So now if I display the current value, it's 35 again. So if I run the whole thing, looks like this. Is that all right? Yeah. Yeah, let me hang out for a second. Right. Okay, so is that making sense?
Yeah.
Okay, cool. Now I want to do the undo thing. So the idea with undo is I'll do it kind of in the middle here. So if the current value is 35, what I want to be able to do is call undo and make the current value 5 again. Right? So one way to think about it is I kind of want to do the same as memory recall, like every time that I do anything, right? So I want to store whatever was the previous value. Does that make sense? So how would I do it? So one way to think about it is like every time I do add or multiply or divide, I just also press the memory button so that in undo, I can press the recall button right away. Now, memory and recall are kind of taken for the memory stuff. So I want to do the same kind of thing, but with a different variable. So I'll say, every time I set current to something new, I also want to say set the previous value to whatever is the current value. So I'll say previous value is current. And I'll do it every time, right? So I'll just say global prev, and I'll say prev equals cur. Say global prev equals cur. Better that I should do global cur at the top. Matters. So now so I haven't implemented the undo yet, right? But now what's going to happen is over here, for example, if I put the breakpoint here. So the current value is 35, but I also have the previous value, right? And then if I do divide by 2, again, the current value is 17.5, but I also have the previous value. And that's just because like in add and multiply and divide, I just say, before I change current, let me store like current and previous. And I overwrite previous every time I do add or multiply or divide. And in fact, I should do it in recall as well, right? So again, same thing. If I do a recall, I want to be able to undo it. So I'll just do, previous equals current. Right? So now, kind of anytime I call a function, I just store whatever is the previous current value to Prev. And now that I've done it, I can do undo. Which is just going to set global. So we're going to have global cur and we're going to have global previous. And initially what I'm going to do is just like current equals previous. Right? So now that it's implemented, I'll put a breakpoint here. So, so I'm over here. So currently cur is 35. And then if I step into undo, what it's going to do is it's going to look at what the value of prev is, and it's going to put prev back into cur. So cur is about to become 5 again. So that's undo. So one flaw in what I wrote is that if I do undo twice, it's not going to do anything, right? So if I do undo again, then what's going to happen right now, cur is 5. And now I go into undo the second time, and cur is 5, and prev is also 5. So you might imagine that that is fine. You might also imagine that you want to like undo the undo, right? So like you might imagine that like you want to like, I'm at 35, undo, I'm at 5, I want to press undo again and get 35 again. So in order to do that, basically what they need to do is they need to swap the values of current and previous, right? So I want to say the new current is the old previous and the new previous is the old current. So that's what we did in lecture actually yesterday, is swap them, right? So the way to swap is you swap them like this, right? So now, so currently prev is 35 and cur is 5. And if you, because kind of undo updates prev as well, right? Sorry, so let me actually do it. So I'll put the breakpoint on 66. So if I step in, right now, cur is 35 and prev is 5. And what we're going to do is we're going to swap cur and prev. Right? Say again? Well, I mean, like I do it for every undo, and the reason is like what does the undo do? It sets current to whatever it was previous, So what I'm doing now as well is I'm updating previous, right? So that the new previous is the old current. So if I go back, so right now current is 5 and previous is 35. If I undo again, they just change places. So now current is 35 again. So that's getting to be a lot. But if I do something like this, so this should print 5, and this should again print 35. So over here, so that printed 5. And now we undo it again, and now it's 35. And now we press memory, and that stores whatever. So that is the undo. I think that's the last thing, right? So let's see. Yeah, so that was like the last question, which was not really easy. Well, like none of them were particularly easy, I think. Kind of if you think about kind of what you would need for this is you need kind of the initial understanding of, okay, I got to communicate to add and mult and divide, and I got to communicate from them. And the way it's set up is that display current value must be able to display the value without having any input. So that must mean that there is this global current value that we have. So I think that's kind of like not an easy insight. I would expect most people would have to like, well, not most, but some people would have to maybe talk to the TA in order to kind of figure out the initial add. Then there's kind of details about kind of division and stuff like that. So like realize that okay, 0, I'd like to do something different. Then I think I would say that memory should be kind of once, so like if you're redoing it, for example, I think kind of once you kind of are able to redo the add multiply functions, I think memory kind of comes naturally because that's like in a way an easier thing to do than to multiply, because all it does is just like sets this new value mem to the current value and then recall gets it back. Right. And then undo, I think kind of follows kind of logically from how memory and recall work. And then kind of the undo is a bit of kind of problem solving where, yeah, like you need to kind of figure it out. So I know how many people got to this, like usually kind of most people I think don't get to kind of this by the end of the lab. So that's kind of difficult. So, yeah. Right.